Drone. When you guys hear that word, many of you think of a super high-tech, unmanned, futuristic-looking aircraft loaded with missiles and cameras, right? However, a drone, by definition, is any unmanned aerial vehicle. It doesn't have to be piloted in any way. It can be anything as long as it's unmanned and aerial. As you can see here, this is the common thing that people see when they think of a drone. It's a Predator drone used in the military, but drones can also be octocopters. It can even be an unmanned plane. As long as it's unmanned and aerial, it is considered a drone. And in this case, quadrotors is what I have today to show you. These machines can be built very cheaply, and they are utilized for anything from aerial videography and photography to inspection of grain bins and elevators to mapping of farmland and mapping areas of low yield or dry patches. Even aiding in the finding of lost livestock is a capability of these drones. This breakthrough in technology has paved the way for future practices of farming, as well as many other industries. With so many technological advancements in the 21st century, things are becoming possible now that were considered insane or stupid 30 years ago. An example of that would be GPS, or the Global Positioning System. Now, GPS hasn't been around for too long, and GPS.gov says that GPS was first used in agriculture in auto-steer tractors and combines. They are now being implemented in aerial videography and photography units, such as quadrotors, and they can be controlled from the ground station and controlled autonomously and programmed to fly to pre-programmed waypoints and return home safely without any input from the pilot. And this you can see, this is a common GPS unit used on quadrotors or multirotors. It's DJI NASA. You can program it from the ground, as I said, and it has auto balance, which keeps it level, position hold, it stays in the exact same position, altitude hold, and auto home, where with the flip of a switch you can program it to come back and land at your feet, which is kind of insane when you think about what we had 30 years ago in terms of this technology. Infrared imaging cameras are also used with these aircraft to monitor crop yield and water tables. These cameras can be built into aircraft to send images back to the computer controlling the UAV or unmanned aerial vehicle. And as you can see from this picture right here, this is an infrared unit, and you can see the red and blue areas, and from that you can tell where the water is and where the water isn't, where your land might need tile or where there's enough tile, or if there's any flooding going on in your land that you can't see from the ground. You can obviously see it from high up with this infrared imaging camera. Now, video transmission has been around for quite some time, really since the invention of the television, but that technology is being implemented in drones as well. Video transmitters and receivers can be set up on drones and programmed to send live and wireless video feedback to a receiver and then transmitted to a monitor to see exactly what the camera is seeing in real time. This poses numerous threats to personal security, but it also helps get a better image of cropland and enables the pilot to operate the machine from great distances, much farther than his or her line of sight. You can see here, you can see right here, this is an example of GPS, or live video transmission. You can see all the altitude and how fast you're going, how fast the wind is. If one were to take all of these technologies and implement them together into one super advanced package, they would get an aerial vehicle capable of flying at distances much farther than the eye can see, an autonomous flight characteristic and an automatic return-to-home function, an ability to monitor altitude, air pressure, temperature, as well as record high-definition video and report back to the ground simultaneously. Current technologies being implemented in the field of drone operation and agriculture include mapping of cropland to find areas with low moisture or areas needing specific chemical application. They can create maps via pre-programmed waypoints that the drone automatically flies to help with this GPS unit. And Juan Valente, a researcher at the Center of Automation and Robotics, says that remote sensed imagery acquired with the miniature aerial vehicles in conjunction with GPS technology enables a meticulous analysis from surveyed agricultural sites. Now, the GPS unit on this quadrotor is actually the control board right here, and you can see this is enabled to fly to pre-programmed waypoints and come back home like I've been talking about without any interaction from the pilot at all. GPS maps used to precisely apply fertilizers and eliminate wasted chemicals as well as reduce environmental damages. They are also used for inspection of buildings where it may be unsafe for an inspector to physically climb or to observe what is being inspected. This will prevent many injuries and may save lives in the long run. As stated before, infrared imaging cameras can be used to find areas of low yield where crops are stressed due to excess heat or lack of moisture. This technology can also be used in combination with mapping and photography to create a specific application plan of chemicals and water to the land. If these technologies keep advancing as fast as they currently are, drones can evolve much faster than just mapping the areas that need chemical to actually applying the chemicals as they are needed. Irrigation can be greatly benefited if these vehicles can become strong enough to carry a large payload of water to custom irrigate the crops as well as auto steer being used in tractors and combines on the farm in recent years. The evolution of UAVs to carry this technology isn't that far off. They have the technology to actually plant crops as well as nourish them throughout their life cycle. Progressive Farmer magazine says that the U.S. is a long way from widespread commercial use of UAVs, and with this new technology in its infancy, no one can really predict where it will be in 20 or 30 years, and we will have to come together to make a decision very soon if and how it will become the next major advancement in agriculture that pushes us further into the 21st century. And the future holds. You can see here, oopsies, right about there. You can see are the days of heavy farming equipment numbered, and no one is really sure if they will be the future in agriculture, but you can see the technology is getting crazy good at making them smaller and making them bigger, and they can evolve to doing much of our agricultural practices that are unsafe for humans to do.